Let's determine the convergence or divergence of the given series. And here's what we're going to do. We're going to actually just use what's called the comparison test. This is a little different from the limit comparison test from some previous examples, but in fact is a bit easier to apply. If we look at this, we'd like to say that it behaves like k to the fourth over k to the fifth. It should behave like sum of 1 over k, because that's the biggest degree and the biggest degree. We could apply the limit comparison test, take the limit, and find that we get 1, but we can actually do something a little bit easier in this case. We can notice that k to the fourth plus 9 is actually just always bigger than k to the fourth, because we're increasing. We can also notice that k to the fifth minus 8 is always less than k to the fifth, because we've always subtracted. Since the numerator is always bigger and the denominator is always smaller, if I divide by a smaller number, that actually means we get a bigger number. So those things together tell me that this is actually always bigger than k to the fourth over k to the fifth. Numerator is bigger, makes it bigger. Denominator is smaller, also makes it bigger. So these things compare in this direction. So what does that tell me? That tells me, well, this is just 1 over k. So the series that we're given, so sum of k to the fourth plus 9 over k to the fifth minus 8. So that means that this is always bigger than sum of 1 over k, because the terms here are always bigger than the terms here. But this one diverges, because that's a p-series with p equal to 1. And a p-series with p is 1 or smaller will diverge. If this is bigger than something that diverges, essentially you want to think about this as saying this is bigger than infinity. If it's bigger than infinity, then this one diverges as well. So if I can compare it directly to something and say it's always bigger than something which diverges, then it diverges. If it's always smaller than something which converges, well then it's got to converge. Because if it's smaller than a finite number, it's also a finite number. And that's the basic idea of a comparison test.